Water has many unique properties. These properties are a result of the structure of the water molecule. In this part of our unit, we will learn how these properties relate to the importance of liquid water for life. Oxygen atoms have 6 valence electrons. To have a complete octet of outer electrons, the 2 unpaired electrons can share with another atom and form 2 covalent bonds. In this image, you can see that the oxygen atom has 8 protons in its nucleus, hydrogen only has 1 proton. So, when oxygen shares its unpaired valence electrons with 2 hydrogen atoms, it has a much stronger attraction for hydrogen's electrons, pulling them closer to its nucleus. A water molecule forms from covalent bonding as the atoms share their unpaired electrons. Shown here are the slight electrical charges that exist on the different parts of a water molecule. Again, because of its larger number of protons, oxygen pulls all of the valence electrons, even hydrogens, closer to itself. This gives oxygen a slight overall negative electric charge. The exposed protons in the nuclei of the hydrogen atoms gives those a slight positive charge. This means that water is a polar molecule and the bonds between the atoms are polar covalent bonds. This means that water is a polar molecule and the bonds between the atoms are polar covalent bonds. When you charge a balloon with static electricity, it will attract a stream of water. The slight positive charges on the water molecules are attracted to the negative charge on the balloon. The polar ends of the water molecule allow these molecules to attract each other and form weak bonds known as hydrogen bonds. While weak, altogether between millions of water molecules the forces can be quite large. Because of hydrogen bonding, water can stick to itself. This is called cohesion. Cohesion holds water droplets in rain together. Water can also stick to other things. This is called adhesion. Adhesion is why water beads up on your windshield during a rainstorm and you should turn on your wipers. The droplets on the ends of these pine needles hold together by cohesion between the water molecules. The drop sticks to the needles due to adhesion between the needle and the water molecules in the drop. Both of these occur due to the polarity of water molecules. To move water from the soil, into the roots, up the trunk, and out the leaves, the properties of adhesion and cohesion play an important role. As one molecule moves up, it pulls on ones beneath it. This maintains a constant flow into, up, and out of the tree. Without this, plants would be limited to being flat against moist ground. As most substances get colder, they contract. Their particles move closer together. This is true for water too, to a point. Water is the most dense, and has the most molecules per cc, when it is at a temperature of about 4 degrees Celsius. As it gets cooler, water forms a crystalline solid with stable hydrogen bonds pushing the water molecules their furthest apart. Ice has formed. There is not much of a difference between water's maximum density and its lowest density, but there is a difference. This is enough to allow water to float, which is very important. Since lakes and ponds freeze from the top, rather than from the bottom up, fish and other life can survive over winter. And we can go ice fishing. Water has a high heat of vaporization. In order to break the hydrogen bonds between water molecules in liquid water, you need a lot of energy. This energy will evaporate the water, changing it to water vapor, a gas. We use this property of water to help cool off on hot days. We seat. The seat evaporates, using heat from our body. As it evaporates, the water in the sweat takes the heat with it. Dogs, like my dog River, can't sweat. This is one reason why she pants. Fog forms over lakes on cool mornings. The water is warm. Warm moist air rises off the water and cools. When it cools, fog forms. The reason why the water stayed warm overnight while the air cooled is that water has a high heat capacity. It is slow to warm up, and also slow to cool. Now that we have taken a closer look at water, it is important to look at another group of substances important to life, carbon compounds.